Good evening, everyone, and welcome to this webinar on the sewer upgrade project for the Maliview service area. I'd like to start with just a few housekeeping items, and then we'll move on to introducing everyone to you. This is our first, or actually our second time hosting this webinar, and we just want to appreciate any patience you can give us with any issues that we have, technical, that we may be experiencing later on in this presentation. We are recording the webinars, and we will most likely be posting one of them to the project page on the CRD's website for viewing if you want to go back and listen to it or get more information. Please ensure that you're muted. We will have a session at the end of the webinar for those of you who are in attendance that have questions. You'll be able to put questions into the chat function, and we as staff will respond to each question at the end of the presentation. That chat function is found at the bottom of your screen. If it doesn't work, we may be able to have the ability to call upon you to actually speak to your question as well. So just to let you know, my name is Carla Campbell. I'm the Senior Manager with Salt Spring Island CRD office. And then I'm just going to hand it over to Alan to introduce himself.
My name is Alan Shu. I'm the Manager of Engineering for CRD Salt Spring Island.
And then we'll hand it over to our consultant.
I am Joseph Bikud. I'm with Associated Engineering and Senior Wastewater Process for the Maliview project.
And just to let people know that we do have our engineering technician, Doug Weiling, with us, and we'll also have a moderator that is also helping us with this Zoom webinar. So I'll hand it over to Alan. He'll start with the presentation.
All right, so thanks for everyone for attending. I'll start with a brief history of the Maliview wastewater treatment plant. So the system was built in the 1970s and was transferred to CRD in 1979. Original treatment plan provide only primary treatment through a spiral jester. In 2005, the plant was retrofitted with something called the RBCU rotating biological contactor to provide additional secondary treatment up to 60 cubic meters a day. And a year after, a primary screening was added to address higher flows through the RBCU unit. So why are we looking at an upgrade for this Maliview wastewater treatment plant? Essentially, we've conducted some study, and it was found that most of the wastewater treatment plant equipment are at or near the end of its life. And there's a few things that we never actually implemented. There's no backup power at this plant, and there's no automated alarm communication system for the plant at the moment. The plant was found to be lacking nitrification capability, and overall it has created a bit of a difficulty and challenges for us to meet Municipal Wastewater Regulation and as well as Federal Fisheries Act requirements. So as I alluded to in the previous slide, in 2011, Stantec Consulting completed a report which has rated the collection system and outflow in a poor condition, and they recommend that replacement of critical components such as motors, bearings, biodisc shaft, and the enclosure to be replaced after 15 to 20 years. That'll put the replacement, starting from 2020 to about 2025. So here, just an example of what we encountered in terms of operational challenges because of lack of backup power. So last December, there was a snowstorm and the power was out at this plant. And unfortunately, the pump isn't going to be functional without electricity. So the sewage was not able to be treated during during the power outage. CRD did respond to this fairly quickly and address it within hours. However, we did have to file an environmental incident report as a result. So another example to give you is, last September we have to replace the failed gear drive for the RBCU unit. We identified the problem at 7:05, and the unit was replaced that exact afternoon. But because of the failure of that critical mechanical equipment, a small amount of untreated sewage was released to the ocean, and we did have to file another incident report. So here's just a similar example where, within about a month of the last power outage, 2 additional power outages occurred due to this time was a windstorm event, and the pump was not functional, and as a result, a small amount of sewage was released, and we had to file another report. Back in about 2018, CRD commissioned a contractor who pushed down some CCTV cameras down the collection pipe. It was identified numerous amount of tree intrusions and gushers where as you can see from the right hand side photo, there's a hole and the groundwater is filling into the pipe, and the left photo just give you a example of where at the joint of the pipe there's a significant tree roots intrusion into the pipe. I do have to say, I guess this particular upgrading project, we're not focusing on the collection system repair. The primary purpose for this upgrade is solely upgrading the waste treatment plant itself. I'll talk a bit later when we discuss the cost estimate on what's the scope of that project is. So besides the aging and failing infrastructure, we had difficulties meeting both provincial and federal regulatory requirements. We had low flows occurring during drier months, which leads to concentrated influent and excessive loads to the wastewater treatment plant, and as a result, relatively poor performance. And during winter months where the high flow occurs, we have occasionally excessive flows that's exceeding the provincial requirements, and that's prescribed to us in the permit. And the Fisheries Act requires, it prohibits deposition of deleterious materials in the water frequented by the fish. During a recent inspection, sampling and testing has shown that the effluent from the Maliview wastewater treatment plant failed the toxicity testing. And it was found out that the concentration is almost like 150% higher than the allowed thresholds. So here's a flow diagram shows you what the current facility and the process look like. So essentially you have the sewage being collected through the collection system, which goes through the receiving box. Previously there was a grinder, now it has been removed. And then the sewage goes through the wet well, then being pumped through a roto screen, a 2 millimeter roto screen. Some of it generates the waste, which was hauled to a different place. And then the liquid stream goes through a settling chamber, further down to a splitter box. Flows that are below 60 cubic meters a day gets fed into the RBCU unit for further secondary biological treatment. The treated effluent meeting regulatory requirements are released to the outflow and then to the ocean. The process does generate some sludge, which are hauled to the offsite. For South Spring Island, it's going to be Bagoing. Here are a few photos to give you a bit of a picture of what the current plan looks like. The first one is the storage building where the instrumentation and a bit of operational equipment are storage. So the top right one shows you that green enclosure is where that RBCU unit is housed. That's the RBCU unit, and here is the spray litter box and the screen. So the third picture shows you what it looks like inside the RBCU unit. So this unit is the RBC disc, where you can see some biological film has accumulated, and that's how the biological process happens and the wastewater get treated. And the last picture shows you what the existing clarifier looks like. So the Maliview wastewater treatment plan is primarily registered under the provincial regulation, the Municipal Wastewater Regulation. It requires that the wastewater treatment plan to be able to treat the wastewater to meet total suspended solids, chemical oxygen demand, as well as pH parameter that was prescribed by the regulation. It also asks us to not discharge toxic effluent to the receiving environment. So because of the small plant discharge nature, which is smaller than 100 cubic meter, this wastewater treatment plant is exempted from the federal wastewater system regulation. However, the Fisheries Act still applies, which requires that the discharge to fish-bearing waters cannot be toxic. So how are we doing in the last few years in terms of the treated effluent as well as the toxicity? We have collected and analyzed the data from 2016 to 2019. So this graph shows you the red line delineates the threshold where the regulation requires us to meet, above which is exceeding not meeting the requirements, because as you can see, the average and maximum combined flows from time to time exceed that requirements. Mostly occur during winter time, whereas there's significant precipitation and significant infiltration and inflow into the collection system. Here's the data in a graph for the effluent, CBOD, and TSS concentration. The orange line delineates the threshold that the regulation requires us to meet, which is 45 milligrams a liter. Again, from time to time, mostly during drier months where the organic loading are high, the plant has difficulty meeting the effluent quality requirements in terms of CBOD and TSS. In terms of the toxicity of the effluent, unfortunately, from time to time, it can reach a significant higher level than what's desired by the regulation. I think the one time when it was tested, it was significantly higher, almost like 3 times of what the regulation was dictated. To minimize the potential for acute toxicity, the wastewater treatment plant upgrading is therefore urgently required so that we can bring the wastewater treatment plant back to compliance. So the regulator has been monitoring the performance of this plan on a regular basis. They conduct site visits on a regular basis. In August of 2019, Environmental Canada inspected this particular site. They connected effluent samples for toxicity testing. And again, we have, unfortunately, the sample failed, both testing, and the result was almost 1.5 times greater than the allowed concentration. So a month after the Environment Canada issued us a warning letter, they have classify this as a the wastewater treatment plant contributes the subsection 36(3) of the Fisheries Act, and they require the CRD to take all necessary corrective actions to ensure compliance. Well, they have also warned us, if we don't take further actions timely, they may consider impose financial penalties, orders, injunction, or the highest level might be a prosecution. The CRD take those kind of non-compliance very seriously. We have assembled a team, and we have provided a written response back to Environmental Canada. In that letter, we outline 3 phases of corrective action with a concrete plan to enhance the facility and bring the facility back to regulatory compliance. So we had 3 phases of action plans. The short-term plan was to implement operational optimizations. Things like increasing sludge hauling frequency do have a bit of positive impact on the effluent quality. That has been, along with other operational optimizations, have been fairly promptly implemented during 2019 and early 2020. And the medium-term action plan involves conducting engineering study and carry out a conceptual preliminary design for the upgrading of the wastewater treatment plant. We have just completed that plan, and we're going to talk about it later in the future slides. And the last 3, the final phase, which is aiming at longer term, is we are committed to the regulator to implement the actual construction of the wastewater treatment plant by the end of 2022, and hoping that with the successful implementation of the upgrading, the effluent quality is going to be brought back to compliance. So similarly, the Ministry of Environment with the BC province also inspected us and issued a written warning letter as well for during the same, pretty much the same time where they discovered that there's potential non-compliance happened at that site. And we again provided action plan back to the regulator, and essentially we're committed to the same thing as implementing the 3 phases of action plans and bring the wastewater treatment plant effluent quality back to compliance. So with that, I'm going to pass it over to Jose to talk about how Associated Engineering evaluated different types of technologies and what criteria we used and how we reached to the chosen technology, which was the MBBR technology.
Thank you, Alan. So yeah, Associated Engineering was retained by the CRD to conduct a feasibility study of the upgrades to the Maliview plant and come up with a conceptual design. So we basically looked at 2 options in the first part of the study. We looked at advanced primary treatment. So just seeing if we would improve the screening, if you could relieve the issues that the CRD was having in terms of the compliance to the requirements of the Municipal Wastewater Regulations and the Environmental Canada Fisheries Act. So we looked at 3 technologies, some disk filtration, a rotating belt filter, and organic harvester. The problem with those technologies is that they would not be able to address the main issue, which is the ammonia toxicity, because the ammonia is soluble, so they would not be able to remove the ammonia, and there's going to be a risk for the toxicity in the final effluent. We then look at different technologies for the biological secondary treatment. The first one would be just to maintain the current technology. So looking at the rotating biological contactor and looking at its feasibility and how we could make it such that it would remove ammonia, which at the moment it does not. Then we looked at other technologies that are still biofilm-based technologies, the moving bed biofilm reactor and the membrane aerated biofilm reactor. And then we looked more at a conventional activated sludge and sequencing batch reactors, just one form of a conventional activated sludge facility. We then looked at a number of criteria. If you could move on. So we looked at the technology maturity, the size of equipment. It's a constrained site, so we want to make sure everything would fit into the required footprint. We look at the ease of operation and maintenance because it's not a facility that's manned 24 hours a day. And ways to improve effluent quality, especially the ammonia, that is one of the main issues. So when we look at those criteria, we ranked those 4 secondary treatment technologies, and we shortlisted 2 that we then conducted a more thorough evaluation. The 2 was the moving bed biofilm reactor and the conventional activated sludge. We then looked at a triple bottom line type of evaluation, looking at technical, environmental, capital, and maintenance costs. And we then basically did a conceptual design for each of those 2 options. The MBBR option scored higher, and the reasons that it scored higher, it was that it has a technical advantage to be more resilient to variation in flow and influent loading, which is fairly high at Maliview, or can be high at Maliview, because of the dry weather you get in the summer and then the wet weather in the winter and early spring. It has a smaller footprint than the conventional activated sludge. It requires less maintenance and operational care required and less capital costs. So we moved on then to do a conceptual design for the MBBR. And the idea was to try to use as much as we could the current infrastructure that is available on site. So we're basically keeping the influent receiving, the wet well, the screen, and the settling equalization basin. And even the RBC, the infrastructure is going to be kept in place. We're just going to repurpose it. So we're going to add 2 tanks or 3 tanks. One stage for the MBBR is going to be removing the organic material, so the BOD. The second one will do the nitrification, where you convert the ammonia to nitrate. And then we're going to need to separate the solids that are generated in this process. So we're going to use a coagulation flocculation tank, add the coagulant, and to help join all the solids together, and then use a clarifier, which is the RBC tank repurposed to a clarifier to settle those solids, and the clarified effluent is going to go through the outfall, and the sludge is going to settle in the bottom, and it's going to be removed periodically and moved to another plant. The other thing that I would like to talk about that is that, so we decided to, where we proposed to increase the capacity of the secondary treatment from 60 cubic meters per day to 100 cubic meters per day, just to make sure all the flows, most of the flows get treated, and the CRD doesn't get into warnings from Environmental Canada related to effluent toxicity. So this is a layout of how the things are going to look on site. So on the top, you have the existing RBC, which we're going to keep that infrastructure of the tank and repurpose to a clarifier. The screens on just on the right, over there are going to be kept, and we're going to reuse, along with a a clarifier that's not shown well there, but it's just below that screen. There's a clarifier. Then it goes to those 2 MBBR tanks, 1 and 2. There's going to be blowers inside the building that's going to push air that is required for the microorganisms to convert the organic material. And then the contents of the tank will go to this coagulation flocculation tank, where a coagulant will be added to help with the settling, and then it settles, and then it goes through the outfall back to the final discharge.
Okay, so with that conceptual preliminary design completed, based on the existing information, we were able to come up with a Class C cost estimate. So we are estimating at this time, based on the existing information, that the upgrading construction, including all labor and materials, is going to be approximately $1.65 million. And on top of that, there's about 12% for engineering, during construction, quality assurance, and project management efforts. Because of the nature that we're still at a conceptual preliminary stage, and the so-called Class C class estimate, typically it has an accuracy of -+25 to 40%. We are allowing about 40% as a contingency, and everything adds up to about $2.21 million. So, the 40% contingency is allowed because, the phase we're at is still conceptual preliminary design. We are still trying to understand, as we proceed further with the detailed design, as we conduct the geotechnical investigation on this site to understand underground conditions at this site. And furthermore, we have initiated some conversations with the regulator. At this stage, we have not yet understand what's going to be the detailed regulatory requirements and any additional requirements that may be required on top of the conceptual preliminary design that we have conducted. So, for that 40% contingency, if it's not required, at the end of the day, maybe return back to the capital reserve. And we are proposing to utilize up to $200,000 towards the repair and replacement of the collection system for a few prioritized areas and sections. As I showed you in the 2 previous photos, the collection system was rated again by the asset management consultant as poor, and we believe that those repairs of the prioritized areas is going to be benefiting and up the status and condition of that pipe to a better condition. So CRD is always on the lookout, and we have submitted a grant application to the Investing in Canada Infrastructure Program in last October, and this plan upgrade is eligible under the green infrastructure category, and which requires that project can result in a wastewater effluent that meets the wastewater regulations or provincial regulations in where there's a federal equivalency. So if we're successful in this grant, the province is going to provide up to 40% combined by a federal contribution of up to 50%. So we, the 2 levels of government is going to provide up to 90%. The ratepayers of Maliview and the CRD, essentially, we need to cover the 10% and any overrun that may occur.
Okay, can everybody hear me okay? I just lost my speaker phones.
Yeah.
Okay. So this is the funding implications that we'll speak to here in this slide here. The debt to be funded will be shared with approximately 94 properties within the service area. As part of the submission requirements for the grant, the CRD had to identify their share of the cost, and they created a bylaw, a loan authorization bylaw 4370, and gave it third reading in November 18th of 2020 to borrow the $2.21 million. The grant is not guaranteed. It is a very, very competitive process. You're competing with a lot of other municipalities for their infrastructure requirements. If the grant is not awarded, the capital upgrade is still required, as outlined above from the orders that the warning letters that we have gotten from the federal and provincial government. The grant required a secured funding plan to cover all the eligible costs of the project, plus any cost overruns beyond the budget contingencies and ongoing operational costs associated with the project. That is why we had to submit a loan authorization bylaw to borrow the full amount, and it was given third reading. That was part of the requirement of the grant. ICIP will not consider any applications if it presents a risks to their program funding, such as if the project won't proceed because there's financial difficulties from the applicant, or if the project does not have public support and the applicant does not demonstrate they're able to maintain and finance the project. The program funder will not wait any score held at third reading and can be amended to the lesser amount if we find out that we are successful with the grant. Want to go to the next slide, Alan? Okay, so we presented to the Maliview Sewer Commission in the fall 2 borrowing options. The first option was to borrow the full $2.21 million, and we show here that there was approximately 3 amortization periods they could have chose from. We recommended the 20-year amortization, and you can see that the annual parcel tax per folio was about $1,519. Of course, this is a projected amount based on an estimated forecast for interest rates at the time that we do go out for borrowing. And then there's the other option as well, is to borrow only a 10% share, and that's the $221,000. And of course, there is the 4 amortization periods that that can be chosen. And you can see that there is a lesser amount of annual parcel tax as a result. There is a, the reason why we're going up for the $2.21 million rather than the 10%, because the grant's not guaranteed. And there is costs associated with going out for borrowing and obtaining the consent of the electors. You can go to the next screen, Ellen. These are 2 options of which we can go out to obtain your consent to borrowing. And we have a survey at the end of this and on our website that we're asking the ratepayers to fill out to kind of give us an indication of what option they would prefer to have their consent taken. The first option we have is called an alternative approval process. This is, some of you may be familiar with, it's called a counter petition. It was the old term. What it means is there's a question, and if you are against the borrowing proposition, all you need to do is sign it and bring it into the office. And if 10% of the ratepayers in that service area are against the borrowing question, the borrowing is quashed. The cost to run something like this is about $20,000. It's mostly due to advertising that we're legally obligated to put into the local papers. And then there's a second option. It's a full referendum with a ballot box. You have to hire poll workers, an election officer, and have ballot boxes. And it is about $60,000 to run because of those labor costs that you have to acquire. So these are 2 options that the community can consider about how they would like to give their consent, or if they'd like to object to it. There's two ways to go about it. And of course, the ratepayers of Maliview are required to pay either one of these options, whatever becomes the preferred choice. The cost of holding that voting option will be borne by the ratepayers. Next slide. So we're here at the end of our presentation. We've got a few questions in the Q&A, and also we're open to having any chats as well. We really appreciate if you could go onto our website here at the link and fill out the survey and bring in your feedback form before April the 6th or on April the 6th at our local office downtown in Ganges at 121 McPhillips, or you can just email it in to our email address right there. We also encourage you, if you have any questions after this and you have a follow-up thing, just reach out to any of us at the office and we'll be happy to answer any of your questions. So the first question we have here, can ratepayers choose a shorter amortization term if the grant is received? It would save a lot over 5 years. Yes, part of that form, that feedback form, we're asking the ratepayers to kind of give an indication of what amortization period they would prefer and which borrowing option they would like to, as well as how they would like to vote. So that's all available to the ratepayers to give us their feedback. We're going to take all of those surveys and roll it up into a report back to the commission so that they can make a decision on the way forward to obtaining consent and what borrowing amounts the community is accepting. I hope that answers your question. Is there any other questions? Let's see, there's 5 people attending. If there's any more questions, we would be happy to answer them.
There were 4 other questions that were
Was
answered.
there?
I don't know if there were 4 other questions that were answered. I don't know if everybody can see the answers.
Oh, right. Okay. So with one question, what was the likelihood of obtaining a grant? We did speak to that, saying it's highly competitive. There's no guarantees. And we most likely will not find out about the grant until later this year, maybe the 3rd or 4th quarter. They're not going to be announcing it anytime soon. And we do have to get ready for borrowing by time the fall borrowing comes in order for us to start this project and complete it in 2022. There was a question about, is it possible to view a map of where the sewer runs to see how intrusive it will be on properties? And we posted a map there in a link on the Q&A chat that you can click on. And I believe the map is also on our CRD's website for this project for the public to take a look at. The other question was, how long will an upgraded system be viable? So further upgrades will be unnecessary. The answer was typically the design has a 20-year horizon. After 20 years, the mechanical equipment will likely require upgrades and/or replacement. And then the last question was, will the added tanks require more real estate? And if so, how will the plant expand? The proposed additional tanks can be fitted within the existing site. So I hope that answers all of your questions. Is there any more?
So, Jose, I mean, I do want to comment a bit on that. Designs, I think it's a design life question. I mean, the design, I agree with you that 20-year design are primarily for the mechanical equipment, but the way I understand it is that doesn't mean a major upgrade will be required after 20 years. I think the way I interpret it is after 20 years, that means some major replacement of equipment, especially mechanical, will be taking place. But things like, buildings or underground tankage, they may last for much longer.
Yeah, exactly. Yeah. So yeah, just the mechanical equipment like pumps and things like that, right? That might be required replacement. There's not going to be much growth, so there's not going to be a need for expanding in terms of size the facility. So it will be just small mechanical equipment that be required. There's no, the tanks probably will last for, I don't know, 40 years. Depends if it's concrete or if it's steel. They may last for a longer time. And the piping as well. And so it's basically be the pumps, probably most likely that are gonna need to be replaced. And perhaps the screen at a later time.
Yeah.
Is there any more questions? Okay, well, I really appreciate everybody taking their time to come to this seminar, and thank you, and have a good night. Thank you, Alan. Thank you, Jose. And thank you very much, Colleen and Doug, who are in the background helping support us.
Thank you.
Welcome, Jill.
Okay, thank you, everyone.
Bye-bye.
Bye.
Bye.